Let's assume that we take the square root of 5 as 2. That means we approximate the square root of 5 by 2. In this case, we make an error in this estimation. We would like to estimate this error that we made when we said that the square root of 5 is 2. If we try and see the calculator, like my calculator here, TI-89, and get an estimate here, so I see that the square root of 5 is 2.23. Okay, if that kind of value, that's the true value to the square root of 5, I'm making an error of 0.23 here. So I'm missing the 0.23 here. Okay, so let's see what we can do and what's the error that we can make and how much can we miss when we say that we approximated the square root of 5 by 2. Okay, and the key here is we will base our approach on the mean value theorem. What can we say in this case? So we know that to use the mean value theorem, we need to have the conditions. We assume that f is differentiable on some interval, let's say on some interval AB, continuous on AB, that's the first condition, differentiable on the open interval AB, and there exists some C in this AB such that f of B minus f of A is equal to f prime of C times B minus A. So if we can find a bound for the derivative, we can see that we can write f of B minus f of A in absolute value is less than, let's say that the f prime of C is bounded by some value m. Okay, therefore we can write f of B minus f of A is less than m times B minus A. Okay, in our case we can think of we can find some function that will give us the square root of 5, and this is the approximate value that we take for the square root of 5. And to do this, we think that the function that we're going to study is, we'll take f of x as the square root of x. And to find an approximation of the square root of 5, we will take the interval for 5. We will see why. Now, using this function here, we see that it's continuous on AB, differentiable on this interval, 4, 5, not including the 4 or the 5, and therefore there exists some C, okay? There exists some C in this interval, 4, 5, such that f of 5 minus f of 4 is less than some bound of the derivative. So let's see that the derivative f prime of C is 1 over the square root of C, and this C is between 4 and 5. And when we try to bracket this one, we see that 1 over 2 square root of C is between 1 over 2 square root of 5 and 1 over 4. Okay, and this means that this is less than 1 over 4 times B minus A, which is 5 minus 4. Let's write it here to check that it's the right one. And this means that f of 5 minus f of 4 is less than 1 over 4. Okay, f of 5 is the square root of 5. F of 4 is the square root of 4, which is 2. Less than 1 over 4, which is 0.25. Okay, we see here that when we approximate the square root of 5 by 2, the error here is 0.25. okay? Because the square root of 5, as we see, is 2.23. And here we are close to the true value if we take this error into account. If we say that the square root of 5 is 225, we are very close to this value. Therefore, when we approximate the square root of 5 by 2, where the error that we are making is 0.25. Okay?